Hey, so in this video we're going to talk about initialization with inheritance, so how initialization is going to work with inheritance. We haven't really talked about constructors and destructors with inheritance so far, so that is really what we are going to talk about in this video. And here in Visual Studio I have this quick example. I have this class base, the base being short for base class, and in the public section I have a constructor which prints out base class constructor invoked. I have a destructor as well, which prints out base class destructor invoked. In the private section, just for illustration purposes, I have an int x which I initialize to 1 just so it has some value, and then we have the derived class which publicly derives from the base class. In the public section, I have a constructor, and this default constructor prints out derived class constructor invoked, and then we also have a destructor which prints out derived class destructor invoked. In the private section, we have an int y which I initialize to 2. Also for illustration purposes, we'll talk about that a bit later. Okay, in main I construct base, which is of type base, and I construct derived, which is of type derived. I'll just comment the derived one out for now. So we instantiate the base class and I'll build and run. And as we would expect, the user-defined default constructor for the base class gets invoked, and it prints out base class constructor invoked. Following this end of program console output that I have, so once we reach the closing curly bracket of the main function, the local objects are destroyed, and so we get base class destructor invoked. So I'll uncomment this line right here where we instantiate the derived class, and then right here we comment out the line where we instantiate the base class. So we're only constructing a derived class now. As you can see, the base class constructor is invoked first, then the derived class constructor is invoked, so that base class part of the derived class is constructed first, and then we construct the derived class part. Then following the end of the program, again when we reach the closing curly bracket of the main function, those local objects are destroyed, and now the derived class destructor is invoked first. Okay, so the derived class part is cleaned up first, and then the base class destructor is invoked, so we clean up the base class part last. The destructors are basically called in the reverse order of the constructors. Also, I'll place a breakpoint right here, and then I'll run the local Windows debugger. In the locals window right here, we have derived. I'll click on this drop down, and now we can see what forms part of the derived object. We have a base part, and then we have the part that is specific to the derived class. We can see right here, derived, which publicly derived from base. In the private section, we have int y. Y is initialized to 2, alright, and that is specific to the class derived. Then we also have this base part, and here x is initialized to 1. Okay, and x is part of that base class part. So you can think of a derived class as being made up out of the part specific to the derived class, so its own members, and then also its parent, so the base class or the parent class, and the base class members, so whether those are inaccessible to the derived class or not, those still do form part of the derived class as we've seen. From our observations, we can see that the derived class is basically made up of the base part and the specialized derived part. And when we do construction, the base part is constructed first, followed by the construction of the derived part. And with destruction, this is reversed. The derived part is destroyed first, and then the base part is destroyed. So what does not get inherited? Well, the assignment operator is not inherited by derived classes. Alright, so let's say you have a user-defined overloaded assignment operator that is not inherited by the derived class. I would like to note that all other overloaded operators are inherited. Now constructors are not inherited, destructors are also not inherited, and then friends are actually also not inherited. Of course, it does make sense for us to inherit things like the constructor or the destructor, because let's say I have some private member pointer and that points to some dynamic variable on the heap. Maybe that is allocated in the constructor. But of course the derived class does not have access to the private members of the base class or of the parent class, so you cannot go and destroy or deallocate whatever that private member is pointing at. Right, the private member pointer from the base class, you cannot go and deallocate that in the destructor of the derived class. On the one hand, this is a nice thing because each class is now responsible for its construction and destruction, so its cleanup tasks as well. So how do we initialize the base class part that forms part of the derived class? Well, a base class constructor must be invoked as part of the initialization of a derived class. The base class constructor that is to be used for the initialization is specified in the initialization list of the derived class constructors. Okay, so if you have a constructor in the derived class, then in its initialization list, you can specify the base class constructor that is to be used for the initialization of the base class part of that derived class. As you can see in this example, we have class derived, which publicly derives from the base class. And in the public section, we have a constructor derived parentheses colon, which indicates a initialization list, base and parentheses again, which indicates an invocation of the base class constructor. And that is a comma separated initialization list, so you can always initialize the members that are specific to the derived class in that list as well. And of course, you can do whatever you want in the body of that constructor as well. Okay, in this example, the base class has two constructors. The default constructor will print out the base class default constructor invoked, and it will set x to 1 in the initialization list. And then in the second constructor, it will print out overloaded constructor invoked. In the initialization list, it will set x to a parameter, an integer parameter that we pass in. This time x is in the protected section. In the previous subsection, we had it in the private section, but I want to use x in the derived class, so I made it protected. Okay, in the derived class, we actually have three constructors. This one right here, which will set y to 2. Y is an integer in the private section. Alright, so this is the default constructor, which will set y to 2 in the initialization list. It will print out derived class default constructor invoked. Okay, so these cout statements are simply for us to see what's going on. The second constructor will print out derived class overloaded constructor invoked. And in the initialization list, it's going to initialize y to what we pass in as an argument. Alright, so as a formal parameter, this has an integer called yp. And then we have a third constructor, and this constructor has two formal parameters, so it takes in two arguments, one to initialize x and one to initialize y. But of course, x is part of the parent or the base class, and we are going to initialize that base part of the derived class in this way. So we do base, parentheses, and then we pass in the parameter, and this is going to use the overloaded constructor, this one right here. So in this initialization list, this is a comma separated list. We can also initialize the members that are specific to the derived class, in this case y. Okay, we can initialize right here. So you might be thinking, what about these other constructors? How are they going to initialize the base part of the derived class? Well, since we do not invoke a specific constructor for the base class, it is going to use the default one, which is this one. So x is going to be initialized to 1, and it will print out the base class default constructor invoked. Right, in both cases where we use these constructors. But in the third constructor for the derived class, we do go and specify which constructor of the base class we want to invoke. Of course, if you wanted to do the default constructor, you can do it in this way. Or if you have multiple constructors in the base class, then you can specify the arguments right here. Okay, so this xp that we pass in, that again is going to initialize x in the base part of the derived class. And just for debugging, I have this toString function which will print out x and y. And that is why I made x here protected, so that I have access to it in the derived class, so I can print it out right here. So I can print out x and y. Right, in main I instantiate derived, and then I do derived.toString. So this construction is going to use the default constructor for the derived class, this one right here. So it's going to set y to 2. And because we do not specify a constructor to be used for the initialization of the base class part, it's going to use the default constructor of the base class. So x is going to be 1, y is going to be 2. If we build and run that, that is what we get. X is 1, y is 2, base class default constructor invoked, derived class default constructor invoked. Now construct this derived object, I'll pass in an integer of 5. And that will initialize y to 5. Okay, it's going to use this overloaded constructor right here, which will initialize y. Once again, since we do not specify a base class constructor in this initialization list for the initialization of the base class part of this derived class, it is once again going to use the default one, the default constructor. Build and run base class default constructor invoked as we would expect. Derived class overloaded constructor invoked. X is 1, Y is 5. Of course you can name these members something else, so base class member, derived class member, something like that if you want to. I just used X and Y here. Then we have another constructor. Control Shift spacebar and we can see the constructors that we have. We have the one that we use currently, the default constructor. Then we have a constructor that takes in 2 arguments for X and Y. Okay, now you can think for a second what's going to happen. It's going to call a derived class constructor that accepts 2 arguments, which is this one right here. Then it's going to call the overloaded constructor for the base class to initialize the base class part of the derived object. And it's going to do that by passing in the X parameter. And then with the second argument, it's going to initialize the part that is specific to the derived class, in this case Y, using the Y parameter. Build and run that. We get base class overloaded constructor invoked, derived class overloaded instructor invoked, and then X is 5 and Y is 10, as we would expect. So that works fine. Again, in this constructor, it uses the overloaded constructor to initialize the base class part of the derived class. Okay, so it's going to use this. That parameter that gets passed in is going to be used to initialize X. And then Y is specific to the derived class. So as you can see in your constructors, you can initialize both the parent part using parent constructors, and you can also initialize the parts that are specific to the derived class.